I know all you guys know what will happen if I throw something up. It will come down. And I'm kind of sure you know that's because of gravity. But what is it? What is gravity? All of us have heard the story of Sir Isaac Newton and the apple. He was sitting under a tree and all of a sudden an apple fell on the ground. Or on his head? Well, I like to think it fell on his head. And that got him wondering, why did the apple fall down? Why? This was the starting of probably the most famous discovery of Newton. Start of a deeper understanding of our universe. So, here he was sitting under the tree when the apple fell on him. That's when he had his grand realization. There must have been some force pulling the apple towards the earth, or else it would have flown away. He termed this force as gravitation. His study into this force not just got him to understand why things fell on the ground, but also on understanding our universe and its laws that govern them. And that is what we are going to focus in this particular video. So why did the apple fall down? We all know Newton's third law, which states that if an object A exerts a force on object B, then object B must exert a force of equal magnitude and opposite direction back on object A. So based on that, there is a force where the earth is pulling the apple towards it and a force where the apple is pulling the earth towards it. But which one has a bigger mass? The earth, obviously. So hence the apple falls down rather than the earth goes up. Now you might ask, what about the moon? What about the moon? Isn't the earth pulling the moon towards it? But then again, the moon doesn't come crashing to the earth like the apple. Well, if it did, we all would be extinct by now. To see what's happening, let's get into an experiment. Let's make some observations here. Before the thread was released, the stone moved in a circular path with a certain speed and with changes in direction at every point. We also know that if there is a change in direction of something, there is change in velocity and acceleration. Also, if there is acceleration, there must be a force. The force that causes this acceleration and keeps the body moving along the circular path and is acting towards its center. This force is called centripetal force. In our case, the force acted on the stone and the thread. Let's implement this same concept to the moon and the earth. The moon revolves around the earth because of centripetal force. The centripetal force is provided by the force of the attraction of the earth. If there was no such force, the moon would fly away tangentially, just like how a stone did in our experiment, if you remember. So, gravitation is defined as the force of attraction between any two bodies in the universe. Remember, the earth attracts or pulls all objects lying on or near its surface towards the center. The force with which the earth pulls the objects towards its center is called gravitational force of the earth or gravity of the earth. Newton noticed the gravitation is similar whether it is the earth and the apple, earth and the moon, or sun and the earth. So he proposed the universal law of gravitation. The attractive force between any two objects in the universe is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. The direction of the force is along the line joining the centers of the two objects. So now let's consider two bodies A and B having masses m1 and m2 whose centers are at a distance d from each other. So according to the universal law of gravitation, the force between two bodies is directly proportional to the product of their masses. F is proportional to m1 and m2. And the force between two bodies is inversely proportional to the square of the distance between them. F equals to 1 divided by d2. Combining equation 1 and 2, we get F is proportional to m1 m2 divided by d2, or F equals to capital G m1 m2 divided by d2. where G is equal to 6.67 into 10 raised to the power minus 11 Newton meter square per kg square and is called the universal gravitational constant. Here's a fun fact. Newton didn't know the value of G, so he just put it as a placeholder. It was Henry Cavendish years later who found out using his very sensitive instruments. Universal law of gravitation successfully explains, number 1, the force that binds us to the earth, number 2, the motion of the moon around the earth, number 3, the motions of planets around the sun, number 4, the occurrence of tides is due to the gravitational force of the attraction of the moon. And number 5, the flow of water in rivers is due to the gravitational force of earth and water. Now that I have explained you the theory behind gravitation, let us get into some problems. Find the gravitational force between earth and an object of 2 kg mass placed on its surface. Given mass of the earth equals 6 into 10 raised to the power 24 kilogram and radius of the earth is 6.4 into 10 raised to the power 6 meters. So here you have to find out gravitational force between the earth and an object of mass 2 kg. Given mass of the earth ME equals 6 into 10 raised to the power 24 kilogram, mass of an object MO equals 2 kilogram, radius of the earth R equals 6.4 into 10 raised to the power 6 meter, gravitational force F, that is the value we have to find out. So F equals to capital G ME/MO divided by D square by universal law of gravitation. Hence, F would be equal to 6.67 into 10 raised to the power minus 11 multiplied by 6 into 10 raised to the power 24 multiplied by 2 divided by 6.4 into 10 raised to the power 6 whole square, which equals 19.5 Newton. Let's do another example. The mass of the mass is 6.39 into 10 raised to the power 23 kilogram and that of the Jupiter is 1.89 into 10 raised to the power 27 kilogram. If the distance between Mars and Jupiter is 749 into 10 raised to the power 3 meters, calculate the force exerted by the Jupiter on the Mars. Capital G is 6.7 into 10 raised to the power minus 11 Newton meter square per kg square. So here you have to find out the force exerted by the Jupiter on the Mars. So given the mass of the Mars is small m equals 6.39 into 10 raised to the power 23 kilogram, mass of the Jupiter Mj equals 1.89 into 10 raised to the power 27 kilogram. Distance between the Mars and Jupiter small d equals 7.49 into 10 raised to the power 5 meter and capital G is 6.7 into 10 raised to the power minus 11 Newton meter square per kg square. So the force exerted by the Jupiter on the Mars would be F equals capital G mass of Mars multiplied by mass of Jupiter divided by d square, which is distance between them square, which equals 6.7 into 10 raised to the power minus 11 multiplied by 6.39 into 10 raised to the power 23 multiplied by 1.89 into 10 raised to the power 27 divided by 7.49 into 10 raised to the power 5 whole square, which equals 1.44 into 10 raised to the power 29 Newton. Thus, the force exerted by the Jupiter on the Mars is 1.44 into 10 raised to the power 29 Newton.